I often tell my students that life is a word problem. That's because in the real world, we solve problems. We do not solve equations. We must be able to use our knowledge of mathematics to write the equation needed to solve the problems that we encounter. Word problems give us an opportunity to practice translating verbal problems into mathematical equations. In this lesson, our problems will result in equations that are quadratic. Remember, this means that our variable will be to the second power, or squared, in our equation. Previously, we have worked word problems that resulted in linear equation. Let's review the steps that we learned to go through when we solve those types of word problems. Our steps for solving word problems is to first read the problem to decide what the problem is about and what you are to find. Second, label a variable to represent what you are trying to find and write expressions for other unknowns. Third, if possible, sketch a picture and write down any formulas that would apply. Fourth, reread the problem for detail and translate it into an equation or formula. Fifth, we will solve the equation. And then number 6, check your answer to see if it is indeed a correct solution for the problem. Now, since our problems are going to result in quadratic equations, and we have previously learned how to solve quadratic equations, I would also like to review the steps that you go through in solving a quadratic type equation. Let's look at those steps. First of all, remember, write the equation in the standard form. That's where we have everything on one side of the equation, and remember 0 on the other side. It's very important to get that 0 on that side. Number 2, we will factor the polynomial. Third, set each factor equal to 0. Number 4, solve each of the resulting equations. And number 5, check your answer. It is very important, particularly with word problems, that you do check your answer. You'll find in the examples that we do today, sometimes the solutions we have to the equations we've written down are not solutions to the word problem itself. Now that we have seen these steps and reviewed them, let's see how we apply the steps to solving a particular word problem. Find 2 consecutive odd integers whose product is 47 more than their sum. Notice here we are to find 2 consecutive odd integers. Now, remember, consecutive odd integers would be, for example, 3 and 5 or 7 and 9. To move from one odd number to the next consecutive odd number, you would have to add 2 to the first number. So let's choose the variable x, and we're going to write let x equal the first odd integer. And since we have to add 2 to that to get to the second odd integer, x plus 2 is going to equal the second odd integer. Now that we have labeled our variable, and a picture here is inappropriate, we're going to look closely at this problem to see if we can write an equation. Let's see what we know about these odd integers. Notice we are told their product, and then there's that word is that I'm always looking for in these word problems. Is, remember, is translated equals. So I have the product here equal to something. The product means to multiply. So I will multiply the first odd integer x times the second odd integer x plus 2. That product is equal something. Now let's look back at the problem to see what this is equal. 47 more than. The words more than indicate add. So we're going to add 47 to their sum. Okay, well, let's write 47 plus, and it's talking about their sum, meaning the sum of these 2 odd integers. So I need x plus the second odd integer, x plus 2. We have the product is 47 more than the sum of our two odd integers. Now, to work this equation that we have written down, our first step would be to remove parentheses. So let's distribute our x over here. We have x squared plus 2x is equal 47 plus x plus 2. We will now combine like terms here on the right-hand side of this equation. X squared plus 2x is equal to 47 plus 2 is 49, and x plus x is 2x. Notice we have our variable to the second power indicating our quadratic equation. So I must put this in standard form. Since our x squared is on the left and it has a positive coefficient, we will be bringing these terms to the left-hand side of our equation. So we will be subtracting 2x and we will be subtracting 49. That will give us x squared. Since we're subtracting 2x, I will not have an x term. And I'm subtracting 49, so minus 49 here, equals 0 on the right-hand side. I have a difference of squares on the left. So to factor difference of squares, we get conjugates of the square roots. X plus 7 times x minus 7 equals 0. Setting each of these factors equal to 0, and then solving each of these equations for x, we have x equals negative 7 or x equals positive 7. You'll notice here that we have two choices for x. So we're going to need to check both of these solutions. Let's start with the negative 7. I'm going to come right up here. If our first odd integer x is negative 7, then negative 7 plus 2 would be negative 5. So we have one possible combination of two consecutive odd integers here. Our second choice is a positive 7 for x, and then 7 plus 2 would give me a 9 for the second possible pair of odd integers. Now, we do have two pairs of consecutive odd integers. Let's check to see if it fits what the problem is indicating. Notice on our first pair, the product of negative 7 and negative 5 is a positive 35. Does that equal 47 more than their sum? If I add negative 7 and negative 5, I have a negative 12. Well, 47 plus a negative 12 does give me 35. 35 does equal 35. So this pair of consecutive odd integers is a solution to our problem. Let's check the other pair. The product here, 9 times 7, is 63. Does that equal 47 more than their sum? 9 plus 7 is 16. If we add 47 and 16, we get 63. 63 does equal 63. So this second pair of odd integers is also a solution. You will notice here that we had two possible solutions to our problem. This is not necessarily uncommon when you deal with quadratic equations. However, sometimes both of these solutions do not work, so it will be very important, as you'll see, that you do check these answers. Let's take a look at a second example. The sum of two numbers is 5, and the sum of their squares is 29 halves. What are the two numbers? We have been asked to find two numbers. Now this time we are not told that they are consecutive, nor odd, nor even. We don't know about that. So for a moment here, I'm just going to write down something for the first number and something for the second number, and I will need to decide what I want to do over here in terms of choosing a variable. Notice in this first sentence, I'm told that the sum of these two numbers is 5. Since I don't know anything else about the numbers, I'm just going to let x be my first number. And then I'm going to try to use this sentence to write an expression for the second number. So let's think for a minute. If I know that two numbers add to 5, if I said to you one of those numbers is 2, wouldn't you subtract 2 from 5 and say that 3 is the other number? In other words, the number that you are given or that you know, you would subtract from 5 to get the second number. Since we are choosing x to be our first number, if we subtract x from 5, we would get our second number. Notice I said subtract x from 5. It's very important that we write this in the correct order. We must take our known number x from 5 to get our second number here. Now, let's see if we can write an equation since there's no picture that we could draw for this problem. Notice here we are told the sum of their squares, there's my is. Sum means I'm going to add their squares. If you square something, you raise it to the second power. So I'm going to raise the first number to the second power. I'm going to raise the second number, which is 5 minus x, to the second power, and I will do their sum. That means I will add those together. That is or equals something. I have the sum of the squares of these two numbers. Now, it says it is or equals 29 halves. So I'll write 29 halves on the other side. Now, looking at this equation, if we're going to solve it, the first step would be to remove the parentheses. That means we need to square this binomial. So let's bring down x squared from this term. Remember, in squaring a binomial, you will square the first term. 5 squared is 25. You multiply the first term times the second term. That gives you negative 5x. And then you double that answer. So we would have a negative 10x here. And then you square the second term. If you square negative x, you get a positive x squared equals 29 halves. Since I have two like terms over here, I'm going to add those. 2x squared plus 25 minus 10x is equal 29 halves. Now, that fraction can make things a little bit more difficult if I choose to let it. However, remember that when you have fractions in an equation, you can clear the fractions by multiplying both sides of the equation by your common denominator. Since we only have the one fraction, our common denominator is 2. So I'm going to multiply both sides of my equation by 2. Distributing over here, I have 4x squared plus 50 minus 20x. And on this other side, notice our 2's cancel, and so we have 29. We do have a quadratic equation, so we need standard form. I will have 4x squared. I'm going to put the minus 20x in the middle position, and then notice I'm be subtracting 29 from 50. That gives me a positive 21 is equal 0. Having this in standard form, I need to factor. I do not have a common factor here, so I'll just need to factor this. I think I will try 2x times 2x first to see if this will work. Remember, if this combination to give 4x squared is incorrect, I'll need to try the combination 4x times 1x. We have like signs, both are negative, so let's put those negative signs in. Factors of 21 that we can try would be either 21 times 1 or 3 times 7. I believe we can use the 3 times the 7. Notice our outside product here is negative 14x. Our inside product is negative 6x. If we add those, we have our negative 20x for the middle term, and a negative times a negative gives us our positive 21 third term. Now, we will set each of these factors equal to 0. 2x minus 3 equals 0. or 2x minus 7 equals 0. Solving for x, in this first equation, 2x equals 3. Dividing by 2, x equals 3 halves. In our second equation, 2x equals 7. Dividing by 2, x equals 7 halves. Again, we have two choices for x. So let's try our first choice of 3 halves for x. If I do 5 subtract 3 halves to get that second number, put 5 over 1, this is 10 halves, subtract 3 halves, which gives me 7 halves for my second number. 3 halves plus 7 halves is 5, so our numbers add to 5. If I try the sum of their squares, if I square 3 halves, I have 9 fourths. And if I square 7 halves, I have 49 fourths. Adding those, I have 58 fourths. Common factor of 2 here gives me 29 halves. So the sum of the squares is 29 halves. Now our second choice for x was 7 halves. But notice, if I use 7 halves for x, then 5 subtract 7 halves would be 3 halves. And we've already checked that that sum of squares is 29 halves. We do have two solutions here, but notice it's really the same solution. It really doesn't matter if 3 halves is the first number or the second number. There's only one pair of numbers whose sum is 5 and whose sum of squares is 29 halves. Now that we have done these two examples, I'm going to give you two problems that I would like for you to try on your own. If you will pause your tape when you see these problems on the screen, then you may work the problems, and when you have finished working these out, if you will restart the tape, then I'm going to work them here on the tape so that you can check your answer to see if you have the correct solution. So let me give you the problems and you copy them down. Let's take a look and see how you did on these problems. Your first problem says the sum of two numbers is 9. The difference of their squares is 45 less than their product. What are the two numbers? We're looking for two numbers here, so we will need an expression for the first number and an expression for the second number. Using this first sentence, since the sum of the two numbers is 9, if we choose x to be the first number, if we subtract that first number x from 9, then we will have our second number. Now, looking at the problem, the difference of their squares is. Difference means we're going to subtract the squares. Our first number squared would be x squared. We're going to subtract. The second number would be 9 minus x. We have to square that also. We have the difference of the squares of these two numbers, and that is or equals 45 less than their product. Now, when you see the word less than in a problem, 45 less than means that you need to take 45 away from. When you're subtracting 45 from something, the 45 needs to be written last. So we need the product, take away 45. The product of these two numbers would be written x times 9 minus x, and then we're going to take away 45. Notice on this right-hand side we have 45 less than the product of these two numbers. In this equation, when you're removing parentheses, you're going to need to be very careful because of the negative sign here. So as we work this out, I'm going to suggest that for now you keep your negative sign and you use a parenthesis. We will square 9 minus x and put that result inside this parenthesis first, Then we'll remove the parenthesis using this negative sign. Squaring 9 minus x, 9 squared is 81. Multiplying these two terms, we have negative 9x. If we double that, we have negative 18x. And then squaring a negative x, we have a plus x squared. That equals 9x minus x squared minus 45. This negative sign is going to change the signs of these numbers here. We have x squared minus 81 plus 18x minus x squared equals 9x minus x squared minus 45. On the left-hand side, notice x squared minus x squared adds to 0. So we have a negative 81 plus 18x equals 9x minus x squared minus 45. This term still has x to the second power, so it is still a quadratic equation. Since our coefficient here is negative, let's take this term as well as all of the others to the left-hand side in order to have a positive coefficient on x squared. Adding x squared to both sides, I have an x squared over here. Subtracting 9x from both sides, 18 subtract 9 gives me 9x. And then adding 45 to a negative 81, I will have a negative 36 equals 0 on the right-hand side. We are now ready to factor. X times x. Notice because of our negative third term, we will have opposite signs in our factors. We need factors of 36, whose difference is 9 since we'll have opposite signs. That would suggest using 3 and 12. If I want a positive 9x in the middle, my 12x product needs to be positive and my inside product of 3x needs to be negative. I have x squared, positive 12x minus 3x is positive 9x, and I have negative 36. This product is equal to 0. Setting each of these factors equal to 0, and then solving for x, I have x equals positive 3, or x equals negative 12. Let's start with x equals positive 3 and come back up here. If my first number x is 3, 9 subtract 3 would give me 6 for my second possible number. Notice the sum of these two numbers is 9. Let's check this, the difference of their squares. If I take 3 and square it, that's 9. Subtract 6 squared is 36. Does that equal 45 less than their product? Their product is 18 minus 45. 9 subtract 36 is a negative 27. 18 subtract 45 is also a negative 27. So these do equal each other, and this would be a correct solution to our problem. Let's try the second combination. If x is negative 12, notice this says 9 subtract negative 12. So that would be plus positive, remember. That would give us 21. Is the sum of negative 12 and positive 21 9? Yes, it is. Let's check this difference of squares thing. If I square negative 12, I get 144. Subtract. Now, I don't recall what 21 squared is, so let's multiply 21 times 21 up here. Looks like we're getting 441 equals. Now, on this other side, I want 45 less than their product. The product of negative 12 times 21 is a negative 252. Subtract 45. Let's scoot that over. 144 subtract 441. The difference here is going to be negative. 4 from 11 is 7. I've borrowed. 4 from 13 is 9. And let's see, I borrowed again. 1 from 3 is 2. So I have negative 297 over here. And on this side, these are both negative, so I'll add and keep the negative, and that is also 297. So this is also a correct solution. Your second problem was to find two consecutive even integers whose product is 12 more than the smaller integer. We were looking for two consecutive even integers. If we let x equal the first even integer, to get to the next consecutive even integer, we would have to add 2. X plus 2 will be the second even integer, whose product is the product of these two integers. X times x plus 2 is or equals 12 more than means 12 plus the smaller integer. Well, this first integer is going to be smaller than the second one, so we want the smaller integer x there. Clearing our parentheses, we have x squared plus 2x equals 12 plus x. Since this is quadratic, we will put this in standard form. X squared, x subtracted from 2x gives me a plus 1x, subtract 12 equals 0. I'm ready to factor. I will have x times x. I will need opposite signs. I'm trying to get a plus 1 in the middle. So if I use 4 and 3 with a plus sign on the 4 and a minus sign on the 3, I have negative 3x plus 4x is 1x, and I have my negative 12. Setting these factors equal to 0, and then solving them, I have x equals negative 4 or x equals 3. Negative 4 is an even integer. But notice 3 is not an even integer, so I'm going to eliminate that possibility from consideration. If this first integer is negative 4, for my second integer, negative 4 plus 2 is negative 2. I have two consecutive even integers here. Their product, multiplying these, I have a positive 8. Is it 12 more than the smaller integer? Remember, negative 4 is smaller than negative 2. 12 plus a negative 4 is 8. So we do have a correct solution here. Our two consecutive even integers are negative 4 and negative 2. I hope that you were very successful in working these two problems. Now, the next problems that we look at are going to be a little bit different. They're going to involve some geometry formulas that you have had in the past. Let's take a look. The length of a rectangle is 3 feet less than 4 times the width. If the area of the rectangle is 85 square feet, what are the dimensions of the rectangle? We are asked to find the dimensions, notice that's plural, of this rectangle. A rectangle has length and it has width, so we need to find both of these. Before we decide which of these we would like for x to be, let's look at the problem again to see what might be the easiest. In our first sentence, the length of a rectangle is 3 feet less than 4 times the width. You'll notice that the length is being described in terms of the width. That suggests that it would be much easier for us to choose x to be the width of this rectangle. And then with that in mind, 3 feet less than means we need to take 3 feet away from 4 times the width. If x is the width, 4 times the width would be 4x, and we need to take 3 feet away from that to have 3 feet less than 4 times the width. Since this problem involves a rectangle, we can sketch a picture of a rectangle. We have our length is 4x minus 3, and our width is x. Notice in the problem in our second sentence, we are told the area of the rectangle is 85 square feet. We must remember that the area of a rectangle is found by multiplying length times width. Let's write that formula down. Area of a rectangle equals length times width. We're simply going to substitute into this formula. Do we know A? Yes, we do. The area was given as 85 square feet, so A is 85. Do we know L? L is length. You'll notice we have an expression here, 4x minus 3 for the length, times width. For width we have x, length times width. Let's clear the parentheses. 85 equals 4x squared minus 3x. We have a quadratic equation. Since our coefficient is positive, and we're here on the right-hand side of this equation, let's just subtract 85, and we'll put our 0 on the left-hand side this time. 4x squared minus 3x minus 85 then is equal 0. I do not have a common factor here, so I'm going to simply try to factor this particular problem. Now 85 is a rather large number, so in thinking about that and getting a small difference here, I think I'm going to try 4x times 1x first in this problem. If this doesn't work, I'll come back and try the 2x times 2x. I'm just thinking ahead a little bit that since the numbers that will be factors of 85 are probably pretty large, I may need to multiply one of them by 4 so that we will have a small difference. 85, in terms of factors, of course, we could use 1 times 85. I know 5 is a factor of 85. If I divide 5 into 85, I get 17. So these are my two choices here. I will have opposite signs. Using the 5 here so that I'm multiplying it by 4 and the 17 here, my outside product is a 20x, my inside product is 17x. The difference here is 3. Since I'm wanting a negative 3, if I make this outside product become negative and the inside product positive, then I will have my negative 3x, and notice negative 85. The next step is to set each of these factors equal to 0. Solving this first one, I have 4x equals negative 17. Dividing by 4, x is negative 17 fourths. Our second gives us x equals 5. Remember that x is the width of a rectangle. It is not logical for the width of a rectangle to be a negative quantity. So we're going to cross out this possible solution since it couldn't possibly be an answer for our word problem. So the one solution that we have that we can check is for our width x to be 5. If x is 5, 4 times 5 is 20, 20 minus 3 is 17 for the length. Notice that our length is 3 less than 4 times our width. The area, if I multiply length times width, 5 times 17, we've already noticed over here, gives us an area of 85. So our correct solution is for our length to be 17 feet and our width to be 15 feet. The height of a triangle is 4 inches more than the base. Find the base and height if the area is 30 square inches. Right here, find the base and height. I will need an expression for the base of this triangle and a second expression for the height. Which of these do I want to choose x to be? Well, let's look. The height is 4 inches more than the base. He's describing the height using the base. Let's let x be the base. Then the height would be 4 inches more than, that would be 4 inches plus the base x. We have an expression for both base and height. Since this is a triangle, let's draw a picture. We have x for the base, and remember height is from a vertex down perpendicular to the base. This height is 4 plus x. We are told the area is 30 square inches. Again, we're going to be required to remember a formula from past experience. The area of a triangle is 1/2 times base times height. Let's fill into our formula. Area is 30 square inches, so we'll place a 30 in place of A. I have 1/2 times B. Our base, B, is x, and then our height, h, is 4 plus x. Let's clear the parenthesis. 30 equals 1/2 times 4 is 2x, plus 1/2 x times x is 1/2 x squared. Since we have a fraction in this equation, let's clear the fraction. Let's multiply both sides by 2. 2 times 30 is 60, equals 2 times 2x is 4x, plus 2 times 1/2 gives me 1x squared. We have a quadratic equation. The positive coefficient is here on the right-hand side, so we'll subtract the 60 and place this in standard form. X squared plus 4x minus 60. We need to factor. Of course, we have to use x times x. We will have opposite signs for our factors of 60. There's a lot of choices for the factors of 60. We're wanting to pick factors whose difference, since we have opposite signs, is 4. 6 times 10 is 60, and there's a difference of 4 here, so let's try those numbers. If I put a plus sign on this 10 and a minus sign on the 6, we have a plus 10x, minus 6x is plus 4x, and we have our negative 60. Setting each factor equal to 0, and then solving, I have x equals 6 or x equals negative 10. X represents our base. 6 is a possible choice. 4 plus 6 would give us 10 for the height. Notice that our height is 4 inches more than our base, and if I do the area, 1/2 times base 6 times height 10, 1/2 times 6 is 3, times 10 is 30. So this is a correct solution, 6 inches and 10 inches. X equals negative 10, since x represents the base of a triangle, would not make sense. We cannot have a negative base, so we will rule that possible solution out. The longer leg of a right triangle is 6 meters less than twice the shorter leg. The hypotenuse is 3 meters less than twice the shorter leg. Find the lengths of the 3 sides of the right triangle. We're looking for the lengths of all 3 sides of our right triangle. Remember, in a right triangle, the 2 sides that form the 90-degree angle are called the legs, and the side opposite the 90-degree angle is called the hypotenuse. We are looking for the two legs. I'm going to call these shorter leg and longer leg, since that's the wording in the problem. And then we will also be looking for the hypotenuse. Before we choose X to represent one of these, let's look back at the problem. The longer leg is 6 meters less than twice the shorter leg. He described the longer leg using the shorter one. Notice he also describes the hypotenuse here using the shorter leg. So the easiest thing to do will be to let X be the shorter leg. Let's go back. The longer leg is 6 meters less than twice the shorter leg. We need to take 6 meters away from twice the shorter leg. Twice the shorter leg would be 2x. We're going to take away 6 meters. Our longer leg is 6 less than twice the shorter leg. The hypotenuse is 3 meters less than twice the shorter leg. So, similar manner, we have twice the shorter leg, take away 3. You'll notice in this problem, we have just used all of the information in the problem to write down the expressions for the shorter leg, longer leg, and the hypotenuse. We are not given area or any other information about this right triangle. Let's draw a picture. I have a right triangle here. And this looks like the shorter leg, so I'm going to call that X. The longer leg being 2x minus 6. The hypotenuse being 2x minus 3. Is there any property of a right triangle that we can use here that we know is always true, but has not been specifically addressed in this problem? We can't always be certain of area or perimeter or anything like that, but if you recall, we had the Pythagorean Theorem that is true about any right triangle. The Pythagorean Theorem, most students remember, says something like a squared plus b squared equals c squared. Most students remember that formula, but it's also important to remember what A, B, and C represent. A and B represent the legs of the right triangle, and C is always the hypotenuse. So we're going to use the Pythagorean Theorem with the expressions that we have written here. One of my legs is x, so in place of a, I will use x. I have x squared. Plus, in place of b for my second leg, I need to have 2x minus 6. So I will square that leg. This equals the hypotenuse 2x minus 3 squared. We will need to remove parentheses. X squared plus, squaring the first term here, I have 4x squared. Multiplying these, that's negative 12x, times 2 is negative 24x, and then plus 36 equals, squaring this one, 4x squared. Multiplying these two, I have negative 6x. If I double that, that's negative 12x. And squaring negative 3, I get a plus 9. On this side, I have 5x squared minus 24x plus 36 equals 4x squared minus 12x plus 9. Since this is the largest coefficient, let's subtract the 4x squared from 5x squared to keep a positive coefficient here. Subtracting 4x squared, I get 1x squared here. I will then add 12x to both sides, so this will be a negative 12x here. And I will subtract 9 from both sides. This gives me a positive 27 is equal 0. I'm ready to factor. I have x times x. You'll notice I have same signs. Both are negative. The factors of 27 that I need to use here are 9 and 3. Minus 3x minus 9x is a negative 12x, and a negative 9 times a negative 3 is a positive 27. Setting my factors equal to 0, and then solving them, I have possible solutions of 9 and 3. Let's try this 9 for my shorter leg. If my shorter leg is 9, 2 times 9 is 18. 18 subtract 6 would be 12. And then for the hypotenuse, 9 times 2 is 18. 18 subtract 3 is 15. We will see if that fits the Pythagorean theorem here in just a moment. Now let's look at our second choice for x. If x is 3, 2 times 3 is 6, subtract 6 is 0. Can our longer leg be 0? No, that doesn't make any sense, does it? So this x equals 3 is not going to work as a possible solution. These numbers fit our definition as given in terms of the relationship between the shorter leg and the longer leg in the hypotenuse. Let's check to see if it does fit the Pythagorean theorem. Is 9 squared plus 12 squared equal 15 squared? 9 squared is 81. 12 squared is 144. 15 squared is 225. If I add 81 to 144, I do get 225. So these numbers are correct. Our measurement was in meters. So 9 meters, 12 meters, and 15 meters would be the lengths of the three sides of this right triangle. An object is projected vertically upward from ground level with an initial speed of 72 feet per second. The equation that gives the object's height above ground level is h equals negative 16t squared plus 72t, where h is the height measured in feet and t is the time measured in seconds. When will the object be 32 feet above ground? We are asked to find when. When is a time. Now the nice thing about this particular problem is that we are given the equation right here. Let's write down that equation. H equals negative 16t squared plus 72t. And we're told that t is time and h is a distance or a height measured from ground level. We are looking for when. So t is what we're looking for, the time when the object is 32 feet above ground. You see what we're doing here, we're looking for t, but we are given h, 32 feet above ground. So we want to substitute for this h 32 feet. 32 feet equals negative 16t squared plus 72t. Now, in terms of drawing a picture here, we are on ground level and we are projecting an object up. We know that as we throw something up, because of gravity, it will eventually stop and come back down and hit the ground. Now, we were at ground level and we're just trying to find when the object will be 32 feet above ground. Let's solve this equation and then we're going to talk about the solution and what it might imply. I have a quadratic equation here. Because my coefficient is negative, I'm going to choose to bring these terms to the left-hand side. 16t squared minus 72t plus 32 is equal 0. Now it looks like this time I have a common factor for these particular numbers. In fact, I see that I can divide by at least 8. Let's factor 8 out and see what happens in terms of these other numbers. If I divide 16t squared by 8, I get 2t squared, minus 72 divided by 8 is 9t, plus 4 times 8 is 32, and I did pull out the largest common factor. Now, we'll bring that 8 down, and we'll see if we can factor this second one. I'll have to have a 2t times 1t here. Same signs, both negative. Let's see, if I'm trying to get a negative 9, I need to use a 4 here and a 1 here. That gives me negative 8t, minus 1t is minus 9t, and notice I have the plus 4. Since this factor 8 cannot be equal to 0, I will set the factors 2t minus 1 equals 0 and t minus 4 equals 0. Solving for t in my first equation, I have t equals 1/2, and in the second equation, t equals 4. Is it appropriate to have two possible solutions? I might mention that had we gotten one of these numbers to be negative, we would not use it, because time in seconds cannot be negative. These are both positive answers. If you look at our picture that we've drawn, it is logical to have 2 times for this to be equal to 32 feet, because you'll notice at every place in our drawing except at the very top, there will be 2 different times that our object is at each height. One time going up and then another time coming back down. So evidently, a half of a second after this object is projected upward, we are at 32 feet, and then 4 seconds later, it's again at 32 feet on its way back down to the ground. We're going to do like we did earlier in this tape. Now that you've seen these examples, I'm going to give you some problems to try on your own. So again, pause your tape and work your problems. When you finish, come back and we'll work them together. Well, let's see how you did on these two problems. The base of a triangle is 1 foot more than twice the height. The area is 52.5. Find the base and height. Since you're looking for both the base and the height, you will need an expression for each of these. Before you decide which of these you should let x be, look back at your problem. The base is described in terms of the height. So it would probably be easier in this problem to let x be the height. The base is 1 foot more than twice the height. That would be 2x plus 1. We have a triangle, let's sketch a picture, whose base is 2x plus 1 and the height is x. Our problem concerns area. Our formula, area equals 1/2 base times height. Substituting into the formula, the area A is 52.5 equals 1/2. Our base is 2x plus 1 times height x. In solving this equation that we've written, we need to rewrite this mixed number as an improper fraction. Multiplying our denominator 2 times 52, we get 104, plus 1, we have 105 over 2 is equal. On the right-hand side of this equation, we are multiplying 3 numbers. When you multiply 3 numbers, you multiply any 2 of those together and then take that product times the third number. I'm going to choose to multiply these 2 together first and then multiply by the 1/2 last. You certainly could do this in another order. Multiplying x times 2x plus 1, we have 2x squared plus x. Now we will distribute that 1/2. 105 over 2 equals 1x squared plus 1/2 x. Let's clear out our fractions, multiplying both sides by 2. The 2's over here cancel, leaving 105. And over here I have 2x squared plus 1x. To get standard form, we will subtract the 105. 2x squared plus x minus 105 is equal 0. To factor, 0 equals, we must use 2x times x, and we will have opposite signs in our factors. Let's see, 105, we of course could use 1 times 105. Since 5 is a factor of 105, that would be 5 times 21. 21 has a factor of 3, so I could put 15 times 7 here. Or using the 5 and 7 together, 35 times 3. We are trying to get a plus 1x in the middle, and whatever we place here is times 2. I think this is the combination that we want. If we place 7 here and 15 here, our outside product is a 14x. If we make that product negative and the inside product positive 15x, we have our plus 1x and we have our negative 105. Setting our first factor equal to 0 and also our second factor here. In our first factor, solving, 2x equals negative 15, x equals negative 15 halves. And from our second factor, we will solve and get x equals 7. Since x is the height of our triangle, it does not make sense to be negative, so we will disregard that solution. Let's look at this x equals 7. Our units was feet. If x is 7, 2 times 7 is 14, plus 1 would be a base of 17 feet. Our base is 1 foot more than twice our height. Checking the area, 1/2 times a base of 15 times a height of 7. We have 1/2, 7 times 15 is 105, and 1/2 times 105 is 52.5. So our correct solution is our base of 15 feet and a height of 7 feet. The longer leg of a right triangle is 12. The hypotenuse is 3 inches more than twice the shorter leg. Find the length of the hypotenuse. Now in this problem, the only thing I'm asked to find is the hypotenuse. But before I just write down x equals the hypotenuse, I remember from having read through this that he described my hypotenuse in terms of my shorter leg. So even though he does not ask for the shorter leg, I want to write that down and choose x to be the shorter leg. Then, looking at this sentence, the hypotenuse is 3 inches more than twice the shorter leg. I can write 2x plus 3 for the hypotenuse. Now, just to complete having an expression for each of these sides, we were given that 12 was the longer leg. So let's go ahead and write that down. We are working here with a right triangle. Let's sketch a picture. Shorter leg x, longer leg 12, and hypotenuse 2x plus 3. Again, since we are not told anything otherwise, we will have to rely on our Pythagorean theorem. A squared plus b squared equals c squared. These being our legs. So x squared plus 12 squared equals, our hypotenuse is 2x plus 3 squared. X squared plus 144 equals, squaring 2x, I have 4x squared. 3 times 2x is 6x. If I double that, I have a plus 12x. And squaring 3, I have a 9. I'll get my standard form over here. 0 equals 3x squared plus 12x. Subtracting 144, I have a negative 135. I believe 3 is a common factor on this right-hand side, so let's factor out 3. Gives me x squared plus 4x minus 45. And then continuing to factor, we will have to use x times x. We will need opposite signs. I believe we can use 9 times 5 here with a plus on the 9 and a negative on the 5. Minus 5x plus 9x is 4x, and we have our negative 45. Of course, 3 cannot be 0, so we will say x plus 9 equals 0, or x minus 5 equals 0. Solving for x, negative 9 or positive 5. Of course, negative 9 is not logical for the length of a shorter leg in a triangle, so we will rule that answer out. X equals 5. Our units are inches here, so our shorter leg is 5 inches. 2 times 5 is 10, plus 3 would give us 13 inches for the hypotenuse, which is what we were asked to find. Now, our hypotenuse is 3 inches more than twice our shorter leg. Let's make sure we really do fit this Pythagorean theorem. Our shorter leg is 5 squared plus the longer leg 12 squared. Does that equal our hypotenuse 13 squared? 25 plus 144, does that equal 169? And of course, when we add over here, it does equal 169. So our correct solution for the hypotenuse is 13 inches. I hope that you have found this tape to be helpful. If you find that you need additional help with solving this type of word problem, I encourage you to take advantage of our math lab or see your instructor. Almost anything requires a lot of practice if you want to be really good. Solving word problems is no exception. But remember that if you're going to practice, it's very important to practice correctly. I wish you good luck with working your word problems. As a courtesy to the next student that uses this tape, I would appreciate it if you would rewind this tape before you turn it back in. Thank you very much.